Hello everybody, we're starting a new pre-calculus lesson 5.2, verifying trigonometric identities. Our learning objectives: verify trigonometric identities and determine whether equations are identities. Now in this lesson we're not introducing any new identities, we're just verifying identities, which means, if we have something like this, is the left side equals to the right side. Same thing here. What we usually do is work with one side and try to get it to look like or to be equal to the other side. You usually work with the side that's more complicated. In this case, the left side is more complicated. In this case, the right side is more complicated. So let's start with the first one. Secant square theta cotangent square theta minus 1 equals cotangent square theta. Let's do something here. Secant square is 1 over cosine square. So 1 over cosine square theta times cotangent square is cosine square theta over sine square theta minus 1. We can cancel these out, so we're left with 1 over sine square theta minus 1 equals 1 over sine square is cosecant square. Cosecant square theta minus 1. We know from the Pythagorean identity cosecant square theta minus 1 is actually cotangent square theta. So we proved that the left side equals cotangent square theta, which is the right side. Okay, and we're done here. Let's move on to the other example. Tangent square theta, tangent square alpha equals secant alpha, cosecant alpha, tangent alpha minus 1. So let's start with the right side. Secant is 1 over cosine alpha. Cosecant is 1 over sine alpha. Tangent is sine alpha over cosine alpha minus 1. This cancels out with this, so 1 over cosine square alpha minus 1. 1 over cosine square alpha is actually secant square alpha minus 1. And from the Pythagorean identity, we know that secant square alpha minus 1 equals tangent square alpha. Why? Because the tangent square alpha plus 1 equals secant square alpha. Okay, so if you bring the 1 to here, it will be minus 1, which will equal tangent square alpha. And for this one, just if anybody is curious, we know that cotangent square theta plus 1 equals cosecant square theta. Bring the 1 to this side, it becomes minus 1. So cosecant square theta minus 1 equals cotangent square theta. And we're done here. Pause the video at any time to redo this yourself and try to make sense of it. Let's look at our second or third example. Verify that cosine alpha over 1 plus sine alpha plus cosine alpha over 1 minus sine alpha equals 2 secant alpha. Obviously, the left side is more complicated. We have two fractions. So we're going to use the technique of combining those fractions. Alright, now the common denominator for these two fractions is 1 plus sine alpha, 1 minus sine alpha. We do this, and then cosine alpha times 1 minus sine alpha plus cosine alpha times 1 plus sine alpha. Okay, let's expand the numerator. So cosine alpha minus cosine alpha sine alpha plus cosine alpha plus cosine alpha sine alpha over 1 minus sine square alpha. This is difference of two squares. Okay, a plus b, a minus b equals a squared minus b squared. Alright, let's simplify. These two cancel out. Cosine alpha plus cosine alpha, 2 cosine alpha. 1 minus sine square alpha is cosine square alpha. Why? Because sine square alpha plus cosine square alpha equals 1. Bring the sine square here. So 1 minus sine square equals cosine square. Now, cosine alpha goes out with the 2. So we're left with 2 over cosine alpha, which is 2 secant alpha, which is the right side. So we have been able to verify this trigonometric identity. Please pause the video and try to redo this yourself. Now for our next example, we have verified that tangent x over secant x plus 1 equals cosecant x minus cotangent x. On the left side we have a fraction, so we're going to multiply by the conjugate of the denominator. Okay, and I think we've done this before. So tangent x over secant x plus 1 multiply by secant x minus 1, and same thing on top, secant x minus 1 equals tangent x secant x minus tangent x over secant square x minus 1 equals tangent x. Now secant square x minus 1 is actually tangent square x, because tangent square plus 1 equals secant square. Alright, take the 1 here, minus 1. Alright, so now we have tangent x, secant x minus tangent x. We can divide each term in the numerator by the denominator. So we have tangent x secant x over tangent square x minus tangent x over tangent square x. This goes out with the 2, so we have secant x over tangent x minus, this goes out with the 2, 1 over tangent x. Secant is 1 over cosine x. Tangent is sine x over cosine x minus 1 over tangent is cotangent x. This goes out with this. So 1 over sine x minus cotangent x. 1 over sine is actually cosecant x minus cotangent x, which is the right side of the equation. Alright, so again we use the multiplication of the conjugate of the denominator to do this. Alright, pause the video and try to do this yourself. Alright, verify that sine square x, tangent square x cosecant square x plus cosine square x tangent square x cosecant square x equals secant square x. Now we're going to use factoring to do this. Alright, as you can see right here we have common factor. Let's take that outside, tangent square x cosecant square x into sine square x plus cosine square x. This is one Pythagorean identity. So we're left with tangent square, which is sine square x over cosine square x. And cosecant is 1 over sine square x. This goes out with this. 1 over cosine square x. 1 over cosine is secant. So this is secant square x. Pretty straightforward, which is the right side. Let's move on to another example. Pause the video and try to redo this yourself. Now for our last example, secant to the power 4x minus secant square x equals tangent to the power 4x plus tangent square x. Now on the left side, you can start on either side, but on the left side we have secant square x. We can take that as common factor. Secant square x minus 1. Well, secant square x is actually secant square x minus 1 is tangent square x, right? Yes, and here we have secant square x. Now, secant square x, right here we have tangent square x plus 1 equals secant square x. Okay? So when you bring the 1 here, minus 1, it becomes tangent square x. Now for this secant square x, we can replace that with tangent square x plus 1 times tangent square x. Multiply both factors, tangent to the power 4x plus tangent square x, which is the right side of the equation. Alright, please pause the video and try to do this yourself. Let's look at the summary of the techniques that we used. Start with the more complicated side of the identity, keeping the other side of the identity in mind as your goal. Use reciprocal, quotient, Pythagorean, and other basic trigonometric identities. Use algebraic operations such as combining fractions, which we used, rewriting fractions as sums or differences, multiplying expressions or factoring expressions. Convert a denominator of the form 1 plus u or 1 minus u to a single term using its conjugate. Again, we've used that and the Pythagorean identity. Work each side separately to reach a common intermediate expression. We didn't do that, but sometimes you can do that. If no other strategy presents itself, try converting the entire expression to one involving only sines and cosines, and I think we've used that before. So these are some of the strategies that you can use for verifying trigonometric identities. That's it for today. Please stay safe and see you in the next video. Don't forget to subscribe and leave some comments. Thank you.